For the relation, the table relation. Then the binary, we have three options. We can select one of the option. And one-to-many is a general case, so we can create the foreign key. Don't be confused with the source and destination. Okay, the referencing and referenced. Then, in case of many-to-many, so we create the in between the table relation, then the corresponding the foreign keys. So we are going to create. So since the relational database model does not allow the multi-value, so we can create another table, another relation for such a multi-value attribute. Then the foreign key. Then in case of an array, we can also create another new the table relation, then the corresponding the relationship. At that time, we need to create the composite the primary key for the new relation, new table. Then create the foreign key. Okay, that's the quick summary of that. So from your homework and the practice, pretty much I believe that you are understanding how to map the ER diagram to the relational schema diagram. In case of the super and subclasses, like the specialization and generalization, we talk about the four different options. So for your reminder, the first option use the four So when we have the, for example, employee, SSN key, and other attribute, and so we have the three subclasses. So technician, secretary, and engineer. So when we have such a super and subclasses, so we can, the first option is, so we can create the one table, one relation for each class. In this case, four of them. This is an employee, this is a technician, this is a secretary, this is an engineer. Then they refer the superclass, the relation. This is an employee table, like that. This is a general case, the first option. And second option is we are going to focus on only subclasses. So which means we are going to create the secretary table, technician table, and engineer table with the SSN, the primary key. Then each of them has their own attribute as an attribute of the relation, plus all of these, the superclass attribute will be added. They are not related. There is no relationship. There is no foreign key. There is no dependency. So we don't have to create the foreign key, which means we need to create the same attribute for each the one. In case we have the application that accesses separately, like the only secretary, only technician, only engineer, not the merge, not the together, not combine the transaction, so we'd better select the option 2. Okay, based on the application analysis. So third option is we are going to focus on the only superclass. So we have the one employee, the table relation with the primary key. Then we can create the attribute for the superclass. Plus, we are going to add the technician, secretary, engineer subclass with the job type. If you have used the different the criteria for the subclass, you can add any kind of the attribute to recognize, to understand which one is which. Then we can add the attribute of this one. But this is for only disjoint case. So disjoint, so job type. In case of secretary, we have the typing speed. The other attribute will be null value. Similarly, in case of the engineer, so job type will be engineer. Then we can put the null for the type. Engineer type will be something manager. Like the other will be null, and so on. This is the third option. The last option that we learned the last time is the same thing for up to this one. Instead of job type, So because option 3 cannot handle overlap case, technician as well as the secretary. So we are going to create a Boolean data type later when we talk about the practical implementation of the relational database, which means relational database management system with the SQL. At that time, we will talk about the data type that are used in the database, DBMS. So one of them is Boolean. So because you are in the computer science, so I can directly use the concept of a Boolean, but sometimes, so those who do not have the background in the computer science, I need to explain what is a Boolean then also. So for example, secretary, yes or no. So if that is true, we can put the value of the attribute of the secretary. Similarly, so we have the technician, yes or no. So if true, we can put the value and so on. This is the first option. This is what we learned the last time. So let's take a look at the example of this one. So this is the person entity. So as we have seen before, how many entities? Just one entity. However, it has a lot of super and subclasses relationship. Using object-oriented concepts, this is not very complicated one. So we can just create a person class and inherit. We can create the employee inherited by the person using based on the superclass of the person. So very simple. However, in the relational database model, it's not simple way. So we need to consider one of the options for each, the super and subclass relationship. So for example, how many super and subclasses relationship in this person entity? 1, 2, and this is also 1. Student and student assistant. There's no relationship. Okay? This is a superclass and subclass. How many subclass? One subclass. Okay? So then this is also another super and subclass. This is another super and subclass. So we need to select one of the options for each. For here, also another option, another option, another option. So we need to decide. Okay? Don't be confused. The degree is a multi-valued one, so we need to create another table relation. Okay? That is not part of the step 8, but we need to consider. So for example, let's take a look at this one. Vice versa. So we are going to see what option, which option is selected to create this relational schema diagram. Okay? So don't pay attention to the alumnus, the degree. This is from the multi-valued one. Okay? So you can take a look at the person, employee, alumnus, and the student. First question. So for this, the person, superclass, the employee, alumnus, student, subclasses, 3 subclasses. Among the 4 options, okay, each option is selected to create this relational schema diagram. Option 1, 1 for each. Option 2, only subclass. Option 3 is the type of a subclass. Option 4 is a yes or no, Boolean. So which option is selected? Option 1. So that means 4 person, 1 table. Employee, 1 table. Alumnus, 1 table. Student, 1 table. As you can see here, and also there's a missing foreign key. SSN should go to the here, right? There's a mistake. So you need to add the foreign key of the employee to the person, SSN to SSN, like this one. Okay? So first option is selected. Then next question. Take a look at the employee as a superclass. And staff, faculty, and student assistant is the super and subclasses relationship. It's a disjoint, okay? Then it's a mandatory full participation, and that's it. Then, so we need to take a look at the employee, okay? Employee. Which option is selected to create the employee for these super and subclasses? First option is not, right? First option, if the first option is selected, employee, staff, faculty, student, assistant, all different the table relation. But here is only one, which means either option 3 or option 4. You understand? So either option 3 or 4. What is the difference? Option 3 and option 4. Boolean, or option 3 is type of the subclass. So let's take a look at the staff, faculty, student, assistant. We can see the employee type means option 3 is selected. So let's take a look at whether this is option 3. Employee type, then we can see the position, rank, and what is this one? Percent time. The position, rank, percent time. Okay, so option 3 is selected. Then what about this one? Student and graduate student, undergraduate student. It doesn't specify whether either disjoint or overlap, but this is a superclass, subclass, and subclass. So that from this is the student. So we are going to take a look at the student. It's one entity here, which means either third option or first option. So take a look at which option is selected. Graduate student, undergraduate student. So it's a graduate flag. Flag means yes or no, right? So then undergraduate, the flag, yes or no. So which means option 4. First option is selected to map the student to create the student relation, student table. What about this one? Student and student assistant. Student and student assistant. This is also super and subclass relationship. Like the manager, if you remind the employee, the super and subclass. Manager is a super and subclass. So we need to take a look at which one. Student, the assistant is the student, the person with. So either employee, because the student assistant is also subclass of the employee. Then the student. So which one? Here the student assistant under the flag. Whether student assistant or not, which means first option is selected under student table, student relationship. If there is any attribute related to the student, because this meaning of the percent time is more related to the employee. Because of that, that information is inherited. It's related to this one, so that is the reason we keep the percent time is in the employee. However, if we have any other, very slow, any other, that's it. The attribute that are related to the student in the student assistant, then we can add such a attribute to the next to the student assistant flag. Okay, so first option is selected. Then another one is this one, student assistant and the research assistant or teaching assistant. So we are going to take a look at the student. Research assistant or the teaching assistant. This one is created under employee. I don't know why the textbook put the RA flag and TA flag under employee. It's more like if I were maybe focusing on something as we consider the RA and TA as an employee. Because of that. So, however, if the meaning of the student assistant is more like the student academic, the record or such a transaction, it can be also under the student. So, from here, RA underscore flag, TA underscore flag, and project course, which means which option is selected? The last option, flat, so yes or no. The first option is selected, so finally we can have such a table. However, if you decide to select the first option, so first option for the person and the employee, first option for the employee and staff and faculty, student, assistant, what happened? This employee will be separated. Employee, the underscore staff, employee, faculty, employee, student, assistant. You can create the 3 employee table. Okay? So how do I decide? It's basically based on your application analysis. So if the application access separately employ the staff, kind of the separate the menu or group of the menu, then we can create another table like that. So selecting option is totally depends on your decision based on the requirement and the application analysis and so on. Okay. Any questions? So in your homework, you are going to practice I think one of this, so beaker and says the customer. So in this, the example, this is what? Ternary relationship. So in case of ternary relationship, we are going to create the sale and the salesperson and customer. But focus on this one. This is a super and subclass. So super and subclass, so you need to select one of the option. So this example is for your practice. This is really complicated because of the weak entity. Like here, the port is a weak entity. Weak entity with what? State, country, because it's the identifying relationship. Also, visit is the weak entity. Weak entity with what? The visit, both ship and port. So which means the primary key of the port is what is the name? The P name plus the name of a state and country. So composite primary key. And the primary key of visit is start date, ship name, and the P name. And P name plus this one. So it's a lot, the composite primary. So it's just for your practice. Okay? So just for your practice, you can try this one. It has a lot of weak entity. Instead, in the real database, we do not use such a composite primary key, even though we lose the meaning. Instead, surrogate key, ID, like for example, in this case, a visit ID will be used to keep to make it better performance as well as a better readability. So this is the little bit extreme, the example of using such a mapping. Okay, the last one is the union type. For your reminder, union type is the multiple inheritance, like this one. This is a superclass. However, superclass in this case, 3 of them are combined. So each of them has a different primary key. So which means if I inherit all these primary keys, it has the driver license or the bank name or the company name. So it will be complicated. Instead, we are going to create surrogate key, artificial key. So like the owner ID. So owner ID will be used for this. Then the other, we can select one of the options, just like the step A. So one for each, or the combine, and so on. So in this is one of the example. So this is the first option. We can see the person, bank, and company, and owner. So we are going to create the owner ID as a surrogate key. Each one has even though owner is not defined during the ER modeling, the conceptual modeling, we are going to add the owner ID for each entity table, then the owner ID will be foreign key to the owner subclass. At this time, this owner will be kind of primary, the important, the table relation, unlike the employee case, because this is the kind of type of owner. So this is called the union type. Okay, so that's the end of chapter 8, 9, then what is the mathematics? Math. Anyone? So I cannot find any educational system that ignore the math subject. Depending on the educational system in the country or anyone, so they are different. Some of the educational system focus on the language or the science, but any country, the educational system includes the math. It's one of the most important subject. So why? Do you need the calculus for the shopping or your daily life? Sometimes not. But fortunately, computer science need a lot. But most of the case, even though most of the kids, they will not use the calculus in their life, but they should spend a lot of time to learn the math. Like from the algebra, geometry, and calculus, and even the probability, and so on. So why? Have you ever think about the why math is important? To go to the better college, or the graduate school, or the better salary. So why we are studying the mathematics? Why do you study your mother tongue, the language? So a lot of students in this classroom from are the international students, but no matter where you are from, but each of them has a mother tongue, and you learn the language also. Even though you are fluent in your language, but you spend a lot of time, like in US. So my son is so bad in the language art, so like the reading and so on. So why do you study the language? Communicate, okay? And also you understand the history, culture, emotion, everything through such a language to understand the human being, because we are Homo sapiens, which means, and also one of the characteristics of the Homo sapiens is it's a social animal. So we cannot live alone. Some of people, yes, but in general, so we are living together with others. Otherwise, our ancestors cannot survive the fighting with the dinosaur, or the fighting with even the low temperature natural disaster. But because the human being itself is really the much weaker than other animals, comparing to the tiger or the mammal. So because of such a characteristic, you can survive. But how can make a lot of people as a group? So sometimes we have the blood relationship, like the family, but that's not enough. So we need to communicate. We need to share our experience. So we need to inherit. Some of the experience will be inherited by the DNA code, but it takes a long time, sometimes not. So we teach and learn. So because of that, we need the education. Using what? The language. So each of you guys. Also, we can make such a relationship stronger, strength. So to share the emotion, like the father and the children relationship, worse and worse. But mostly such a family relationship will be. So that is the reason it's also important. So if you are from the other country, so you are fluent in your language, like for example me. So I'm very fluent in the mother tongue Korean, but when I speak or discuss with or share the talk with my son is really hard. Because even though my son understands the Korean, he doesn't understand my feeling. Even especially when I am yelling, he didn't understand what I'm saying. He can feel he probably angry, but he doesn't understand. So such a language is, because of that, so we study, we spend a lot of time to survive. What about the mathematics? So there are a lot of different definition regarding to the math. So one of them, which I believe, the mathematics is also language. The universe, which means it's a nature. It's a language for the nature. Or even if we include our society as an alien, so it's a universe. So we try to, for a long time history of the Homo sapiens and the human being, the people try to understand what is our life, or what is the birth and the death, and who actually controls the world or universe. Somebody believes the God, including me, and the God otherwise it's very hard to explain something. So somebody said that the universe is the expansion, like after Big Bang. What about the outside of the universe? Is there anything other? So even nobody can imagine. So without God, sometimes it's very hard to explain such the nature. So limit within such the universe. So, but still, the people has been spending a lot of time to understand, to figure out what is our life, what is the world, what is the nature. Somebody believed proposed the 5 elements of the nature, like the soil and the water and something like that, right? And people try to understand, to find the basic element of the nature. Then one of the group think about we need something language. That is, this word will be based on the number. Okay, using the number, we try to understand this nature. So then they start from the count, and sometimes count is not enough, or very hard, so we can add something operation like the addition. So 5 and 6. So instead of counting everything, we can use the operation to count. So the mathematics can be used for understanding our nature. So one of the benefits of using the mathematics, the number is, even though notation are different, if one thing is true, so like think about the Pythagorean theorem. So somebody proposed a Pythagorean theorem. So it's the rise, the triangle, the c squared is equal to a squared plus b squared, or the mc squared by the Einstein. So such the proof proved by the mathematics, the theorem will be true anywhere, including universe. If there is alien, so alien may have the same theorem, even though notation may be different. They may not use the 1, 2, 3 number. Instead, they may use the different notation. If they have the 12 finger, well, they may use the not decimal, so probably use the number system. But it's still true. Such a right triangle has the c squared equal to a squared plus b squared, like that. Okay? So that is the power, that is the benefit of the using math. So we need, actually to survive in nature. Okay? And also understanding nature, we need such a mathematics. So mathematics actually does start from such a philosophy. A lot of philosophers, all the Greek and the Roman philosophers, they are the mathematicians. So some of the mathematicians is also philosopher. Then the mathematics start from the 2 way. Okay, one is, for example, there are several origins of the human society. So one of them in India is along the river. the Ganges River. So we consider that is the origin of the human society, the civilization. And another one is in Africa, it's the Nile River. So Nile River is the why along the river we have such a human civilization.
Because for agriculture, that's why most civilization.
So something to
yeah.
That is the ultimate thing. So to survive the human being, we need something to eat. So along the river, it's why the river is, especially the end of the river, it's called the delta. Most of civilization happens such an end of the river facing to the ocean. It's called the delta. So why? What happened at the end of the river, delta area? Always flooding. What happened? The flood is good or not? It's bad because it actually wipe out everything. But after wipe out, what happened? Fish? Can you get the fish after the storm? After wipe out, it's a new soil. It's a fertilized. So if you plant the agriculture, it's much better. So because of that, the most of the city and the civilization starting from such a fertilized the end of not the river. Problem is what? So this is my land. So I do the agriculture and the plant, and so that's it. But so I don't want to. I want to secure my area, but I cannot do the kind of the hire the security guy or whatever. So we need government. So government is the interesting the group. So they actually protect the people. So long time ago it was the kind of king. Okay, king inherit their position power, but the king would like to protect mostly not all the people. So they protect the people who own the land, something like that. But anyway, that's the starting of the government. It's the same thing right now. So government, if government cannot protect their people, we don't need such a government. Instead, it's a free service. No, it's not free service. We need to pay tax. So because of that, so the government can be organized and manage such a thing. So a long time after civilization, even the old government, they need the taxes. So based on what? Size of land. Okay? So they got the tax. But the problem is, after wipe out the flooding, so I want to keep my land. This is my land. This is but wipe out, there's no the boundary. So how can you guys address such a thing? Even government need, because they need to get the tax based on the area. How? So people try to use something such a mathematical way, like so I know that I can measure again here to here, but so using the tree or mountain, crossing the river, so they realize something, the ratio or the rule, okay? So eventually it will be sine, cosine, and so on, which you don't like, but that's called the geometry. So geometry is one of the way to understand the nature, is one of the big branch of the mathematics. Another branch, another way of the mathematics is, so not always, I don't want to measure everything or find the ratio and so on. Instead, I want to understand such a problem using only mathematical way, which means number. Okay? So I don't want to go out to measure the angle and so on. Instead, with my paper, I'd like to define the problem using number, notation, and the operation. Then eventually make the equation. So equation is a really creative way. It's like the statement. in English. Okay, so it is clear. It's very clear, and there's no additional description, just define. So I always say those who are struggling from the math in the elementary school and the middle school, math is really language. So what you guys need to do is there's always question. It's sometimes called the problem solving. So what you guys need to do is translate such English to mathematical language. Mathematical language is the equation. Okay? Once you realize that, to build the equation, what you need? Variable. It's the same as the programming code. First, you need to define the variable. Okay? X, which one is X, which one is Y, whether this is the vector or not, define the variable. Then find the relationship. Then make the equation. Equation is simple, either equal or inequality. Most of that is equal. Then the last thing is evaluation. Solve the problem. And that's it. Math is done. So once the student understands such the mechanism like the translation into the, so much easier to understand the problem. So same thing happened. So people would like to understand such a problem with the mathematical language equation. Okay? So then they solve the problem without measuring or angle or distance, so on, unlike the geometry. That is called algebra. So algebra, that is the reason that if you go back to your the high school and middle school, 1 year you learn the geometry, then the pre-algebra and the geometry and the pre-calculus and so on. So that is the calculus is kind of very interesting subject. Calculus, we like to, in calculus we like to understand the characteristic of curve. That's it. Because a lot of things can be represented in our life, can be represented by the curve, including the line, linear. Okay? So linear equation, or our temperature is the line. And so a lot of things here in this room is also curve, including line. So we want to understand such a characteristic. When you find your friend, girlfriend or boyfriend, you want to understand your friend. Okay? So what is the characteristic? Whether it's really the nice or not. Similarly, when we see the nature, we want to understand using what? Such a mathematical equation. Then the calculus try to give what is the slope, what is the moment, what is the gradient, and what is the minimum, what is the maximum, so on. So as we have seen before in the the database model. Relational database model is based on what? Mathematics, it's a set theory. So far we have used the definition of the relation. What is a relation? And we finally have the relational schema diagram. Our goal is to define and model such a relational database. The schema, relational database is what? We want to use that design the database. Then how to use such a design the relational model. At that time, the modeling include what? The operation. If you think about the class, in Java, when you define the class, the method will be operation or behavior, whatever the name is, we have defined such a method. Using that, the operation and method, we are able to use, manipulate, create, instantiate, and so on. So we want to do the same thing in relational database by defining such a something operation. So how can we define the operation? At that time, we will use such a algebra. Algebra means operation, some number and the operation. So we will see. And also, eventually, we will expand such an idea to the relational calculus that actually specify something condition to access the data. So first, I'd like to introduce relational algebra. We will see. So relational algebra. So relational algebra is just like the mathematics. It's a language. Okay? So language is used in relational model. So in your page 1, you define your query in English, right? So like the retrieve the number of students who registered the database course, like that. Then what you guys need to do is translate such a English statement into the database statement, relational algebra statement, which is called the relational algebra expression. So when nowadays natural language processing, understanding language is one of the important areas of computer science. So language consists of what? So when you study new language, how do you study? YouTube. But when I was kid, when I studied English first time, I start to memorize vocabulary. I know that's not the right way, but when 34 years ago, when we study English, so some of the students actually memorize the dictionary. Then next, learn structure of statement. Subject, verb, object, subject, verb, indirect object, direct object, like that. Then try to read, then you don't understand. Language is not such a way, but our language, database language, we follow such an old-fashioned way. So we will see what is the vocabulary and what is the operation that combine. Eventually, we will create the statement, okay, which is called the relational algebra, the expression. So first, you need to think about the employer, student relation. So we have the UBID, name, the major, GPA. Then this is the relational schema. And this relation has number of data. For example, 111, Lee, and the CS, the GPA is 3.0. And 112, and the Patel, and the CS, and 4.0, like this one. This is the relation that we define. Group of data, group of attribute. So what we want to do in the relational algebra is we are going to define the operation. So operation, the operation that would like to access only specific data only. Okay? So first operation, that is called sigma. Okay? Sigma, the operation. So our operation has always input and output. So input and output. So input is always a relation. Okay? And output is also relation. Then this is first sigma operation has the condition to access the data. For example, this is a student. So I want to access the student. I want to access the student whose major is the CS. Okay? In English. So we try to convert that plain English into the relational algebra database, the language. So to do that, so we can use the first select operation. This is called the selection. So for example, this is a symbol and input is the student. Then we try to specify condition. So condition is the subscript of the symbol. Okay? So which means the GPA, the major is CS, like that. Then only tuple whose major is CS will be returned. So output of this operation is this one, 113 and 112 pattern, okay, whose major is CS with what? All attribute. So this will be returned. So which means, what is the definition of a relation? Group of data. So this is output is also group of data. So output is the also relation, like the student and the CS underscore CS. So output of any relational operation will be also relation. Okay? So this is the selection operation, the first operation. Then I already introduced the second operation. This is called the rename. So rename operation is the arrow. So this is the rename of the relation. So rename of relation is this relation named as the new one. This is the old and this is the new name. So this is a relation, but it's complicated. So we are going to rename as the student underscore CS. So second operation that we are going to use in the relational algebra is the rename operation. So we can use the selection operation a lot for what? Specify any condition. So what about this one? I'd like to retrieve the student whose major is CS and whose GPA is bigger than 4.0. We can add logical operation simply like this. The major is CS and the GPA is equal or bigger than 4.0. Like this. This is a condition. We can use any logical operation, even or, even the parenthesis, anything. Then the input is relation student and rename CS and 4, like this. Or this may be possible because this is the relation and this is also relation. So input of the operation, selection operation is a relation. Is it possible? So STU underscore CS. Use the input of selection again. It's also possible because this is a relation, so we can use as an input of another relation. So we can put this condition for and rename and final result CS4 like that. This is also possible. Okay. Or another approach is, and the first and the second. Good. Is, so why don't we combine this one? So instead of separate this, so we can plug in this one into this, so which means, so this is a student. And the rename output. So 1, 2, 3, all of them are the same. Okay? So this is the characteristic of the selection operation. This is the first relational operation that we are going to learn. At this time, so if we combine into one, this is called, this is a relational, the operation, each one operation, relational operation. If you combine the multiple operation, So this is called the relational expression. So relational expression means kind of a statement. So statement is the consisting of what? Number of words. Okay? So each operation is like a word. By combining number of words based on the rule, then it will be statement. So this will be the relational, the expression, or it's called the statement. It's a relational expression. So our goal is in step 8 is to find the relational expression for what? Your query defined in the page 1. So this is the first operation. I'm going to introduce many operations. It's not actually many, less than 10. So this is the first operation. The second operation is, so we are able to access the by condition, so to retrieve the row. But I don't want to access all attributes because definition of the relation is group of data, group of tuple. Also, group of attribute, group of column. So for example, I want to access UV, ID, and name only. This data. So to do that, we are going to define this operation. This is a symbol pi, and this is called the project. So project operation. So project operation is also same. Input is the relation. And output is also the relation. Then we are going to specify list of attributes that we want to access, okay, as a subscript. For example, so here I want to access the UV ID and name only. So from the student, which means from the student. So I want to limit by the attribute UV ID, comma, and name. You can list up the attribute that you want to access. Then this is the student, the ID, and name. So it can be any name. So it's if you want, this is called TEMP. Okay. So this is the project operation. So project operation is the limit by the attribute. Then all attribute, but only this one will be returned. Same thing. So what if? So TEMP. Then I want to access UV ID. Then only UV ID. TEMP1 has the only UV ID. That works. Also, this is the same as what? TEMP1 is the same as the project UV ID and project UV ID and the name, like the student. So this is the same meaning. You can combine with another project if needed. Okay. One more thing. So this is the rename of the column, but I want to rename of the attribute name because it's too much complicated. So at that time there is another operation which is called the row. So name is, this is a rename, but this is a rename of relation, this is a rename of attribute. So this symbol is called the row. So row is, the input is also relation, and output is also relation. But you are going to specify the new name, new attribute name, list of the new name. So for example, I wanna rename this one into ID, this one into the NN, simplify. To do that, so you can rename TEMP row, and so this is the ID, and this is the NN. Then this is the final result, like this, rename. But at this time, you should be careful. It should be same order, okay? So it's corresponding. The attribute can be renamed as this one. We can combine into one. If we combine into one, so after we retrieve the UBID and the name of student, we can rename the ID and NN, and as a result, which means output of this one will be, instead of UBID, it will be ID, and this is the NN, and only this, the tuple will be returned. This is also relation. It's a new relation. Okay? So this is called the row rename of the what? Attribute. So we have seen already 4 operation. Sigma is a selection. Limit what? Limit the data with the condition. And the second, projection. We are going to limit by attribute. We can give the list of attributes that we want to accept. 2, rename. One is the rename of the attribute. Another one is rename of the relation. So by combining this one, we can create a relational algebra expression. That's the statement. Eventually, that relational algebra expression will be converted to what? Later, it will be SQL. Okay, we will see later. So we already see this operation. As you can see, what is how many relation will be input? One relation, right? Input is always one, the relation. So this is called unary the operation, which means there might be binary operation later. So this is called the unary operation. So it's very simple. That's one of the benefits of using the relational database model. When Dr. Yeh proposed this idea, people really like this approach. Because of the even non-relational database, a lot of the system or model use SQL style, this style, relational algebra style, the language. Okay? So within the 5-10 minutes, we already see the most of the operation using the relational algebra. Okay, so we have seen the select, project, and the rename unary operation. So we will see the others later. So we are going to keep using the same company database. Please, I believe in your mind is already printed, right? So please, even though I do not mention details of this again and again, so if I'm using the company database, it's automatically the database. Okay, so first one is the select, as we have seen just before. It's kind of filtering limit by the data with the selection condition. So selection condition is here. So it can be the logical operation, it can be anything. So for example, if we can apply the commutative, so as we have seen here, okay. So we can cascade, and so I believe that you understand this one. So What is the meaning of this? Very long the condition. It's not very complicated. From employee, there's or the logical operator, so either this one or this one. From department number 4, DNO number 4, from department number 4, whose salary is higher than 25K. So department number 4, the whose salary is 25 or higher. Or the employee in the department number 5, whose salary is 30, will be returned. Okay, that's the meaning of this selection. We can do a lot of things using this selection operation. So output will be like this one. But all attributes will be returned because we do not limit the attribute. So all the data will be returned like this one. Okay? So what if we want to limit the restricted attribute? Attribute can be limited by the project, like this one. We can give the list of attributes as a subscript of the project operation. So it's always same thing. It's the input is a relation, output is also relation. So like this one. So we can use a lot of property. So I believe that you know that this the rule. Like for example this one. Project is not commutative. Why? So if we go back to here, this example. What if I already erased the previous, the erase. So for example, the UBID and name, project, and the UBID, that works. However, if I change it, UBID name, and this one UBID, there's no name here. So we cannot exchange commutative. Okay? I think you understand the meaning of why the project is not commutative. Okay? So let's practice. From the employee, last name and first name and salary. Last name and first name and salary. So what will be the output of this one? Last name, first name, and salary in that order. If you remind the characteristic of the relation is ordered by the attribute. We keep the order of the attribute. We do not keep the order of data. It's not ordered by data, but attribute is ordered. So in that order, employee will be returned. What about this one? From the employee, sales and salary will be returned. So this will be returned. So how many employees? 8 employees. So all 8 employees will be returned. So for example here, Smith, John, and social at the salary, and Wang, the Franklin. It may be changing the order of data. It's okay, depending on how to store the data. But this order will not be changed. It's same order as this one. So 8 of them. What about this? We retrieve the same employee and 4 sex and salary. But how many data? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Where is 1? Null. There's no null data here. Sex and salary.
Index is all?
Index. 1. Anyone? This is correct. We access the same employee table, but output, number of output will be different. So which one? Female 25K. So for example, the Alice female 25K, and Joyce English female 25K. If you remind, so what is the characteristic of the relation? Relation must have what? Primary key, which means unique. So which means doesn't allow duplicate data, redundant information. So why? Output of this operation should be relation. To be a relation, no redundant data. Okay? So automatically this duplicate data will be removed. So only one female 25K. So that's the one difference, the characteristic between relational algebra and if you already know the SQL. SQL does not. SQL does not care the uniqueness, just return as it is. Okay? So we are not talking about the SQL yet. We don't know what is a SQL, the language. Only relational algebra. So relational algebra is the output of any relational algebra operation is also relation, which means no redundant data. So in case such a redundant data, we will remove. So for those who already know the SQL, the several years ago, old version of SQL Server if you select the data, automatically remove the duplicate data. That is a select distinct. Okay? So select the distinct. So to follow the same, the concept as this one. Today, initial version, but nowadays it's different. They do not use the distinct. Why? How can you find the duplicate data? So from here it's easy. So at once we can find how. What if we have millions of employees? Can you find? It's not easy. We need to guess.
What if we added Social Security to that?
Then all data will be returned because they are not duplicate. Social Security number, female, 25K. Different Social Security number, female, 25K.
So
all data. Yeah. Then problem is, why? How to find such a redundant information? We need to sort the data. No other way. Okay? When you see that this one, intuitively, in your mind, it's sorting whether there exists a duplicate data or not. Depending on the intelligence level, may use different sorting algorithm, right? Somebody use a quick sort, somebody use the brute force way. So check whether there exists one and one. But depends on. But anyway, you are using the sorting algorithm. Sorting is very expensive. So whenever we use such a relational, the operation characteristic, which means the removing duplicate, it takes a long time. Okay, so it's very expensive. So later, even Microsoft SQL Server, remove the automatic distinction like this one. However, we are able to do. So during the SQL, we will see the way. Okay, so our goal is to find the relational algebra expression. That's to combine the number of operations. Okay, so like this one. So we can see we can use the rename of the relation for the temporary, the relation name. Later, when we implement the database, relational database in the computer system, which is DBMS, this one will be in the memory. Okay, this is a memory space. So we will see later during the query optimizer. So rename also can be used, and this is the rename of attribute. So we can do a lot of things. So this one. So what's the meaning of this? The A. Retrieve the employee who are in the department number 5. But not just retrieve the all employee, retrieve last name, first name, and salary of employee who works for department number 5. That's kind of a translation. So from this relational algebra expression, you are able to understand the meaning of that. And the database programming means from the requirement, plain English, if you are able to convert math or translate to the relational algebra, then that is the database programming. Okay? So we can use the separate or we can use the combine into relational algebra operation. So next one, what time is it?
46.
46. So next, talk about the union and the binary operation, because the relational model comes from a set theory. Set has a lot of operations. the union, intersection, the minus, and so on. As you can see, so such a set operation will be used for the relational, the algebra operation. Okay, regardless of coverage of the lecture, so we are going to have the simple exercise the next week. Okay, even though I do not cover the simple in the class, we are able to start the learning the SQL using MySQL. So please be ready for your exercise lab on Thursday next week, and please submit your homework to the desk before you leave. Okay, thank you, and see you next week.